India's only active volcano, situated to the east of Andaman Islands, has undergone a volcanic eruption, triggering panic and fear amongst the local community as well as across the geologists of the world. What does this volcanic eruption indicate? Where are barren islands situated? And also, what is the basic formation of Andaman Nicobar Islands? How did these islands come into existence? Along with the relevant previous year questions. That is what we are going to discuss in today's session. Hello and welcome to Unacademy, one stop destination for civil services aspirants. Welcome to this special session where we talk about eruption of the only active volcano in India which has been covering news headlines across the country. Now, India, basically a land which has got many different volcanic landforms, but none of them are active anymore. The only active volcano is situated in the region of Andaman Nicobar Islands. Now, this active volcano basically started eruption in the 1700s, and for a long period of time, it lied dormant. It is from the 1990s onwards where it has indicated frequent volcanic activities once again. As a consequence of that, there have been widespread speculations and estimations regarding how the Indian subcontinent and the plate that is moving. So, what is this theory of plate tectonics and what is this concept why the Barren Islands volcano has erupted? Mind you, while this eruption has been happening in the month of September, along with that, this region has also started to experience seismic activities, which indicates the instability of the landmass underneath. So let us understand this concept. As you can see, it has hogged the national headlines across the various different outlets that volcanic eruption has been observed in the Barren Islands. This has also managed to create a fresh volcanic crater, and you have lava which has started to flow out. Now, while these barren islands, they are not populated, so that is why there is no risk to the human population in that area in itself. But nonetheless, it does have a potential of what lies in the future. Before we talk about it in detail, an important announcement for all of you. Today marks the last day and the final day of Shiksha Mahotsav Triple Treat, where we bring for you a kind of a bonanza for all the 2026 aspirants. If you get a 6-month subscription, you get a 6-month free subscription along with that. For 2027 aspirants with a 12-month subscription, you get an additional bonus 12 months plus a 12-month CSE Assure, where if you are not satisfied, if you are not able to clear the examination, provided you have fulfilled some of the criteria of attending the classes, your next year's preparation is on us. And for the 2028 aspirants, for 18-month subscription, we are providing you with a fresh 18-month subscription free of cost along with the CSE Assure. So, in a way, that is the validation of the amount of materials and also the quality of materials which are provided on the platform that will be sufficient for competing in this examination. Use the code IES English and avail this beautiful offer. Now, having said that, barren islands have erupted previously as well. When we talk about the previous eruptions, the first eruption in Barren Island took place in the 1700s. That is, as per the administrative data that we have. Now, it was followed by mild eruptions in 1991, some minor eruption in 1994 as well, 2005, 2017, as well as in 2022. These are the regions of the Barren Islands. Now, why is it that we have that eruption in the place? But before that, where are these barren islands? So, if you take a look at the location of Andaman Nicobar Islands, barren islands are situated to the east of Andaman group of islands above the 10-degree channel. Now, Barren Islands is situated here, and close to it in the north, you have another extinct volcanic region, and that is the area of Narcondam. Narcondam is an ancient stratovolcano. Okay, so when you talk about Narcondam, it is not active anymore. It is categorized into the extinct phase. So here you basically have older stratovolcano. But then, if you take a look at the location of it, and if you take a look at the region of Andaman Nicobar Islands, you will find a certain pattern in the shape of Andaman Nicobar Islands, which helps you understand that how they have been created. So older stratovolcano. What is a stratovolcano, by the way? A stratovolcano, the term is derived from strata. Strata means layers. So this is a volcanic eruption where you will have subsequent layer formation. One layer of lava formation, above that a layer of ash formation, another layer of lava formation. So these are very large landforms. So you have lava, solidified lava obviously, then the ash deposits, okay? And due to this, the size keeps on increasing. And then again, lava. Oftentimes in these stratovolcanoes, the type of materials also, which are coming out in the form of lava, that also varies from mafic to the case of felsic lava. That keeps on changing. Now, what I want you to observe is the shape of the Barren Islands, and rather the Andaman Nicobar Islands. If you observe, there is a kind of a curve, isn't it? A kind of an arc. These are also what are referred to as island arcs, geographical phenomena, because these are all your islands and these are in the shape of an arc. And if you take a look at the entire map, this is a part of the what is referred to as the Indonesian arc. The region of Indonesia is filled with multiple active volcanic eruptions. Now, Barren Islands is referred to as the northernmost eruption and the northernmost active volcano in the Indian arc, or the rather Indonesian arc. So, when we talk about Barren Islands, this is basically northernmost active volcano. Okay, active volcano in the case of Indonesian arc. So, what does that tell you? That tells you that the same phenomena which would have led to the formation of Indonesia and all these islands and the group of islands which we also refer to as archipelago, that same phenomena would be responsible for the formation of barren islands as well. But if we further analyze the locational aspect, because that can be important for your map pointing as well, in 2018, UPSC had asked a question in the prelims directly based on the location and the phenomena of barren islands. So if you take a look at the entire location of Andaman Nicobar group of islands, barren islands are situated somewhere here. This is where you will find the presence of barren islands. So to the east of Andaman group of islands. So when you talk about Andaman and Nicobar Islands, there are divisions. So the northern group of islands, they are known as Andaman group of islands, and the southern group of islands, they are known as Nicobar group of. The southernmost island is the Great Nicobar Island, which is in a lot of news, lot of discussion nowadays owing to the Great Nicobar project and the environmental degradation and the environmental concerns associated. Now, Andaman group of islands and Nicobar group of islands is separated by a water body that is known as 10-degree channel. Now, why the name 10-degree channel? Because here you have the 10-degree north latitude, which passes through the region. So that is why 10-degree channel. Similarly, in the region around Lakshadweep, around Minicoy Islands, you have the 9-degree channel. So all these channels are named after the latitude which does pass through these areas. Now here, all these islands, by the way, they are either volcanic or coral in origin, but majority of them, they are volcanic in origin. Volcanic origin. But if there is volcanic eruption which has created the Andaman and Nicobar group of islands, why don't we experience volcanic eruption in, let's suppose, the central portion of Bay of Bengal or in the northern portion of Bay of Bengal? Why only in the Indonesian arc? That is associated with the plate boundary and the plate move. So let us understand the reason behind them. So first of all, before going into the details of this plate movement which has led to the formation of islands, one has to understand that what do we mean when we talk about a plate? So plate basically is a fragment of the lithosphere. What is the lithosphere? So the surface on which we are standing upon, that is the portion of crust plus upper mantle. The combination of crust plus upper mantle, that forms what is known as lithosphere. I will show you the map of all the plates as well. So here, this lithosphere is divided into multiple small parts which are known as plates. Now, these plates in themselves, depending upon their size, depending upon their property, they are classified into major and minor plate and minor plate. Example of major plates, for example, if you consider the Indo-Australian plate, is a major plate. It is large. African plate, Eurasian plate. Then you have North American plate, South American plate, Antarctic plate, Pacific plate. All these are examples of your major plate. But then you also have many smaller fragmented plates also. For example, the Burmese plate. Burmese plate was earlier a part of the Eurasian plate itself. It broke down. Then when you consider the Arabian plate, Anatolian plate, Juan de Fuca plate, Cocos plate, Nazca plate, Scotia plate, all these are your smaller plates. Filipino plate, they are in the category of minor. Now, the plate in concern, which is going to help us understand the formation of Andaman Nicobar group of islands, is the case of the Indo-Australian plate, where in this discussion we will consider as the Indian plate. Now, Indian plate consists of the Indian subcontinent. Now, Indian subcontinent is made out of crust, the land masses. Now, those land masses, they have a lighter type of rocks, the granitic aspect of rocks, which have a density of close to around 2.7 gram in general. But then it also includes the portion of oceanic crust. So, any major plate will generally have both oceanic as well as continental crust, other than Pacific plate. Pacific plate is the only major plate which is completely comprised only of oceanic crust. Otherwise, almost all the plates, major plates, will have continental as well as oceanic. When we talk about the Indian plate, the continental crust we know, the land that we stand upon, that is the continental crust of the Indian plate. But the region of Bay of Bengal, some regions associated with the Arabian Sea, that is the oceanic crust of the Indian. Now, that oceanic crust of the Indian plate, when it is undergoing subduction or a kind of a convergence with another plate, then what happens? This oceanic convergence will lead to the subduction of the oceanic crust. Right? Which oceanic crust will subduct? The heavier of the oceanic crust will undergo subduction. Okay, so the basic mechanism, if I can recap it for all of you and if I can elaborate it for all of you to understand the mechanism of movement. So when we talk about the type of crust, any plate, larger plate will have both oceanic and continental crust other than the Pacific. So crust can be either continental or it can be oceanic, oceanic crust. Okay, any of those. Now, oceanic crust is the one which is heavier and denser and denser, whereas continental crust is light. Okay, why? Based on the type of formations and the volcanic eruptions which have led to the formation of these areas. Now, in this particular case, these are mostly made out of granitic rocks. Granitic rocks. And these continental crust, that is very thick as well. Average thickness is close to around 30 kilometers of the crust itself. In certain areas like the region of the Himalayas, the thickness can extend for almost 70 kilometers. That is how much the thickness can be. Whereas the oceanic crust is thinner, right? So the thickness in this case is close to around 5 to 20 kilometers at max, but mostly around 5 to 10 kilometers. It is made out of heavier basaltic rock. Now, here you might have a doubt that even though the continental crust is thicker, why do we consider it to be lighter? The oceanic crust, even though it is thinner, why do we consider it to be heavier? So, the perfect analogy to understand this is the case of a large block of thermocol and a thin sheet of iron. Now, iron is much more thinner, thermocol is much more thicker, right? But then, if I ask you out of A, thermocol and B, iron, which will be heavier? Always iron will be heavier because the density is higher. So basaltic rocks have a greater density. Okay. So that is why you will find that they are the heavier ones. Now, what does happen when, let's suppose, you have two oceanic crust which undergo convergence? Now, which oceanic crust are we talking about? One is the case of the oceanic crust of the Indian plate. Another is the oceanic crust of the minor Burmese plate. Burmese. Now, whenever two oceanic crusts undergo convergence, so in that case, the heavier one, the denser one, will start to undergo subduction. Owing to the force of gravity, the heavier one will start to indicate subduction. The lighter of the oceanic crust will get deformed and will ride overhead above it. So in this case, the Indian plate being the denser one, the Indian plate is undergoing, the oceanic crust of the Indian plate is undergoing subduction. Now, what it does, now this entire region is covered under oceanic water as well. So what it does, at the zone of convergence, there is a kind of a deformity which is created, as you can see, because as the plates undergo subduction, it is never going to be a smooth process, is it? It is always going to be slightly rugged and random movement. The movement is also not going to be smooth. So as these crustal portion or lithospheric portion, they undergo convergence, there is a deformity and a kind of a depression created. This is what leads to the formation of an oceanic trench. Oceanic trench. Meanwhile, the plate which has undergone subduction upon reaching a greater depth experiences such high temperatures that the materials they start to melt. Molten portions or liquid portions are always going to be lighter. So as these lighter portions they start appearing, these lighter portions will have a tendency to rise up. They rise up and they will create volcanic eruptions. The continued subduction of the Indian plate will lead to continued volcanic eruption that will continue, and it will be a long drawn process. Over a period of time, what you are able to achieve in this is the case of an island formation, a volcanic island. Volcanic island. So this is how volcanic islands in the region of Philippines, in the region of Aleutian Islands, in the region of Andaman Nicobar Islands, in the region of Indonesian islands, all of them have been created as a consequence of this. It is this process which will happen in the entire zone of convergence. That is how you have an island arc or a chain of islands which come into existence. But also, there will be a formation of an oceanic trench, just like the Mariana Trench that we have in the Pacific Ocean. So, in the case of Andaman Nicobar Islands, do we have a trench formation as well? The answer is yes. We'll take a look at that. But again, I want you to take a look into the schematic image. So, this is the portion of lithosphere. That is the oceanic crust of the Indian plate undergoing subduction. There will be an oceanic trench created here. And then the molten portion will rise up and lead to the creation of the volcanic arc or the island arc. This is the case of in the portion of Andaman Nicobar Islands, the basic principle of formation. By the way, as this movement of the plates happen with respect to each other, is this movement going to be smooth and flawless? The answer is no. There will be a kind of an interrupted move because these are larger rocks, denser rocks which are trying to rub against each other. So they will offer each other resistance, and eventually, due to the force, they will overcome the resistance. Whenever they will overcome the resistance, suddenly the rocks underneath will, and that will shake the ground surface. That is why these are the regions which are also associated with seismicity or earthquakes. Lot of earthquakes dominate this area. And that is why in the region of Barren Islands also, as these molten materials try to come up, they basically experienced that. Now take a look at the zone of convergence here. This is the area of Barren Islands, by the way, what you can see in the image here. This is the region of the Barren Islands. Observe here that these are the boundaries associated with the Burmese Plate, the minor Burmese Plate. Now here, remember at the zone of convergence, what do you have? First of all, you will find the oceanic trench. So here, the Sunda trench and the Sunda Banda trench complex. Then after that, you have the Andaman trench. The convergence is happening at a rate of around 4 centimeter per year. As a consequence of the volcanic eruption, that is how all these islands of Andaman, Nicobar group of islands, and then the Sumatra group of islands, they also come into existence. And as long as the convergence will continue, till that point of time, volcanic eruption like the Barren Islands will continue to happen. That is why Barren Islands is a perfect example of oceanic-oceanic convergence and a volcano associated with oceanic convergence. But then do we have a similar phenomena in other parts of the world as well? The answer is yes. All across the region of the Pacific, you observe and you come across the same phenomena. So first of all, the details. So here you will observe that the eruption on 20th of September was preceded by a magnitude 4.2 earthquake, right? And this has been happening throughout the last month along the active boundary of the Indian plate and the Burma microplate, the smaller margins of the plate. So this is the portion of the Indian plate and this is the portion of the Burmese microplate. And that is where the convergence is happening. Mind you, this convergence over the land areas is the one which has created the eastern fold mountains. For example, the Naga Hills, the Lushai Hills, the Patkai Bum, Arakan Yoma, Pegu Yoma, Tanaserim mountain ranges, all of them which you find in the Indo-Myanmar bordering area, they have been created due to the same convergence, but their continental crust is involved. So that is a category of continental-continental convergence. But in the region of Andaman Nicobar Islands, oceanic crust is involved. So that is why different kinds of landforms are to be expected. Now, which areas of the world you will find the same phenomena? For example, if you take a look into the northwestern part of North America, there you will find a group of island formation that is the case of Aleutian Islands. Now, these Aleutian Islands have also been formed by the same case of oceanic-oceanic convergence. In this case, there is a subduction of the oceanic floor of the Pacific plate and the oceanic crust of the North American plate. Then take a look at the Mariana Trench and the Philippine group of islands. There also, the eruption has been the volcanic eruptions that you observe in Mount Pinatubo, Mount Tal, Mount Mayon. In all of these areas, you'll find the eruption is happening because of the subduction of the Pacific Sea. Observe, you also have the eruptions in the entire Java Trench or the Indonesian Sumatran region. So that is where you have the Krakatoa eruption, you have Mount Merapi, and here is where you have the Barren Islands. All these are examples of oceanic-oceanic convergence. Similar eruption you observe across the Tonga eruption. That is where you have the Tonga trenches. So many of you would not be aware about the presence of the Andaman Trench. But to the west of Andaman Nicobar Islands, you have a deeper portion of the seawater that is known as the portion of Andaman Trench. Okay. Now, let us take a look at a couple of PYQs associated with this particular topic in itself. Now, the Barren Islands volcano is an active volcano located in the Indian territory. Barren Islands lies about 140 kilometers to the east of Great Nicobar. The last time the Barren Islands volcano erupted was in 1991 and it has remained inactive. Which of the statements given above are correct? Take a look at each of these individual statements and let us know what is the correct answer in the option or in the comment section below. There was another question which was asked. It was location based. Which of the following is geographically closest to the region of Great Nicobar? Sumatra, Borneo, Java, or Sri Lanka? So, which is geographically located closest to the southernmost of Andaman Nicobar, that is the Nicobar Islands. So, again, take a look at this and put the correct answer in the comment section below. But while we are talking about the convergence of the oceanic and oceanic crust, There are other forms of convergences as well. Because when you have an oceanic crust, when you have a continental crust, there can be three possible conditions. One is oceanic continental convergence. Another is the case of oceanic-oceanic convergence. Another is the case of continental-continental convergence. These are the three convergences that happen, right? Oceanic-oceanic we have seen and how they get created. Now let us take a look at oceanic-continental along with the example and the type of landforms created. Then we will take a look at continental-continental. It is the continental-continental convergence which has led to the formation of the Himalayan group of mountains as well. So first of all, when we say the continental oceanic, in this case, what happens? You have at one side the continental crust. On the other side, you have the oceanic crust. Example, where will you find them? So this is the image overall of the plate boundaries across the world. Here, if you consider this end, the western margin of South America, where you have the longest mountain range across the world, that is the Andes. Now here, you have an oceanic continental convergence. Oceanic crust is provided by the Nazca Plate, and the continental crust is a part of the South American. So if you take a look at it, let's suppose you consider the oceanic crust. The oceanic crust is thin and narrow, but heavier nonetheless. Continental crust is very thick, but less in density, lighter in weight, just like thermocol. Now, once the convergence process starts, it is not going to be a smooth process out there. Let's suppose the convergence process starts. So imagine this is the continental crust and this represents the oceanic crust. As the convergence begins to happen, the continental crust will experience some amount of deformation, right? So again, at the margin areas, you can experience the formation of an ocean. But again, as the subduction continues, this continental crust will experience lot of force, accumulation, and a fold mountain creation. So what tends to happen? So observe this. Let's suppose here there is subduction which is happening. Now, due to the subduction, the continental crust also gets deformed. As it gets deformed, there is accumulation or accretion of materials in the coastal areas, which will lead to the formation of a fold mountain case and a fold mountain series. Now, here, as it undergoes subduction, again, what are the landforms that you observe here? First of all, the formation of a trench, isn't it? Then, after that, formation of a fold mountain. By the way, will you observe earthquakes in this region? Absolutely, yes. Again, at the zone of convergence, the movement will never be. So that is why you will experience a kind of the seismicity, because as the crustal rocks they try to move against each other, there will be resistance that will be overcome and they will lead to earthquakes as well. So due to this, there will be seismic effects or earthquakes in this zone. Lot of earthquakes will be observed. Keep one thing in mind: whenever you have the plate boundary, any plate movement will always lead to the shaking of the earth's surface, will always lead to seismic activities. Now, as it goes to the depth, the material then tends to melt. Upon reaching the greater depth, because of higher temperature in the region of asthenosphere, partial melting will happen here also. Now, these liquid portions, being lighter in weight, they will start to rise up. They will go through the continental crust and they will emerge as era. The example that we are taking is the case of South American plate, South American plate with Nazca plate. Okay, that is the example that we are considering. Nazca plate represents the oceanic crust, whereas South American plate, the portion which is undergoing convergence, that is going to represent the continental crust. So here, in this particular example, the fold mountains which are created at this margin is the case of Andes. The trench that is created in this case is the Peru-Chile trench, which is at a depth of 8,000 meters from the sea level to the western portion of South America. So you have Peru Chile Trench. I will show you all of this on the map as well. Simultaneously, you have active volcanic eruption, for example, Mount Cotopaxi. That is the case of active volcanic eruption. Right, Mount Aconcagua is not active anymore, but all those are created as a result of volcanic eruption. Right? So these are the features that you will observe at this particular boundary. As a consequence, observe the formation of Andes with interspersed volcanic eruptions in almost all across the region of the Andes. Right? Here, you will also find in this region the presence of Peru-Chile Trench. The trench formation is observed here. So that is the dynamic or the formation of continental oceanic convergence. It is happening in multiple places across the world, even in the western margin of North America. Rockies formation, coastal Cascade Range formation, all of them are associated with the convergence of the North American plate with the Pacific landmass. All these are continental oceanic convergence zones. Then after that, you have the case of the third type of convergence, that is the continental convergence. Now, what do we understand by the continental convergence? In this, both the plates are going to be light. Both are continental crust. Both of them are going to be very, very light. So if you consider, let's suppose one continental crust, right? Another continental crust. Both of them are light. But when they will converge with each other, when they will converge with each other, there will be combination and deformation which will occur. Crustal thickening will occur. However, whichever is the slightly heavier one will indicate some amount of subduction as well. So, for example, in this particular case, let's suppose we consider the continental convergence that we have in the case of the Indian plate as well as in the case of the Eurasian plate. Eurasian plate. Now, both of them are continental crust which is undergoing convergence. Now you might get confused. Right now you said Indian plate has got oceanic crust. Now you are saying Indian plate has got continental crust. What is the real story? So Indian plate will have both continental and oceanic crust. The portion, for example, northern portion of India and the entire Indian map that you see, that is the case of continental crust. The water body around it, that is a part of oceanic crust. Okay. Now, in this, will subduction happen? Yes. Minor subduction will happen. Minor subduction will happen. At the same time, because both of them are light, that is why you will experience crustal thickening. For example, in the region of Himalayas, the crust gets as thick as close to around 70 kilometers. So you have crustal thickening. Okay. Now, which portion will undergo subduction in this case? Whichever portion has got higher density, greater density, that is the portion which will undergo the slight amount of subduction, whichever portion has got greater density. So in this case, Indian plate has got higher density, greater density. So let's observe the mechanism of convergence, how it works. So when these two plates will converge, crustal thickening will happen, a fold will be formed, which we observe in the form of Himalayas. The crust will be substantially thickened, and some portion of the Indian crust, because it is heavier, will undergo subduction. Okay, so here, very high amount of pressure. Pressure is very high. So when the pressure is very high, the sedimentary and the igneous rocks will get converted into metamorphic kind of rock. Okay. And as the convergence tends to continue, the height of the mountains will continue to increase. Now, because the Indian plate is moving north, Eurasian plate is moving south. That is why the height of the Himalayas continues to increase. Will there be a trench formation in? No, because here you don't have a clear cut subduction as was the case with the oceanic crust. So, no trench formation. Will there be a volcanic eruption? No. Why? Because in this case, very little amount of crustal portion is actually undergoing subduction. So, that partial melt will not be sufficient to create a volcanic lava formation. And at the same time, let's assume, even if some amount of molten material is created, the crust is thickened to such an extent that the lava won't be able to break through the surface. After all, the rocks have also been compressed and the rocks are also getting converted into metamorphic. So it is much more difficult to break through them. But then, as these plates tend to move and rub against each other, these will be areas of very high magnitude earthquakes. That is why the entire Himalayan zone is prone to seismic activities and very, very strong seismic activities. So here, seismicity will be observed, right? That is why earthquakes across Jammu Kashmir, across the region of Leh Ladakh, across the region of Himachal Pradesh, Uttarakhand, Nepal, then all the way till Arunachal Pradesh, Assam, Bhutan, Sikkim. In all these areas, you will observe a lot of these seismic activity. But will there be volcanic eruption? No. The reason is twofold. First of all, crustal thickening, so lava won't be able to come out even if it is created. Second, the amount of material which undergoes subduction is very, very less, so the molten material formation won't be high. What will it lead to the formation of is the case of cold mountain. Okay, mind you, these plate movements are of different types. You have the plates which move away from each other as well. Those are your divergent plates. You have plates which move parallel to each other. Those are your transform plates. We are only talking about the convergent plate, the type of plates which will move with respect to each other towards each other and the kind of landforms that they get to create. So, in this area of the Indian plate and the Eurasian margin, that is where the continental-continental convergence is happening. Older such continental-continental convergence have also happened, leading to the formation of alpine mountain ranges, the Pyrenees in certain areas, and also the region of the Zagros mountain range around the area of Iran. There also you have the crashing of the Eurasian plate. Okay, but in this map you will experience or you will observe that there are a lot of divergent plates as well, transform plate. So when we say the type of landforms and the phenomena that we experience, so what are the phenomena? So you will have volcanism, volcanism, right, and seismicity. Volcanism, when will you observe that? In the case of oceanic subduction, either oceanic or oceanic-continental. Whenever you have oceanic plate involved, you will have volcanism. Seismicity in all plate move. Okay. Then the landforms which get created. So whenever we talk about convergence, different types of landforms get created. For example, in the case of oceanic-oceanic, you will observe the formation of trenches. You will observe the formation of island arcs, even seamounts, underwater mountains, which are volcanic in nature, seamounts, and in general, volcanoes. Okay. In the case of oceanic-continental, again, you will observe the formation of trenches. You will observe the formation of fold mountains. Example, Rockies, Andes, Atlas, all these are created as a consequence of oceanic continental, where are Atlas ranges to the northern portion of Africa. Then, other than that, you also have volcanoes. When we talk about continental, you will have the formation of cold mountains. Example, Himalayas, Alps, right? Ural, these are the case of cold mountains due to continental convergence. But as I told you, the plate movement is not only restricted to it. When we talk about the other type of plate movements, so overall, whenever you talk about plate movement is of three types. One is that of convergence, that we have dealt in detail. Then you have the case of divergence, that is, they are moving away from each other. And then you have the ones when they move parallel to each other, that is transform. Right? They move parallel to each other, neither towards or away from each other. The convergent plate, the three types of convergence that we have considered, in that one of the portion of the crust gets destroyed in the process of convergence. That is why this is also what is referred to as destructive plate boundary. Destructive plate boundary or destructive plate margin. Then divergence, when the plates move away from each other. For example, North American plate is moving away from the Eurasian plate, creating the Atlantic Ocean. So whenever the divergent plate movement occurs, there is always volcanic eruption in between, creation of a new crust. So these are also known as constructive plate margin. Constructive plate, right? And in the case of transform, when they are moving parallel to each other, neither a new crust is created nor a crust is destroyed. So here, in this particular case, conservative margin. Conservative. Okay. These are your three types. Now, if you want to take a look at where this transform movement is happening across the Arabian plate, that is happening even across the Burmese plate. If I can take you back to the particular image, you will observe even across the Burmese plate. Observe this portion. Yeah, there is a movement which is parallel to each other. That portion is neither moving towards or away from each other. That is a transform move. Okay, some portion of even the Philippine sea plate, that is also moving parallel to each other. If you further take a look at the region here, if I can show you the plate boundary, observe the portion in certain areas of the North America as well as in the region of Pacific. There you have some amount of transform movement. Now, this transform movement can lead to creation of large cracks, which again can be center of seismicity. Example, you have the San Andreas Fault in California, which is a center of seismicity or earthquake activity. Okay, so that basically is the entire thing that you need to know for the portion of plate movements and overall the formation of Andaman Nicobar. So what have we considered and discussed in the video? Very quickly, if I can recap it in a couple of minutes, we have discussed what is happening in Barren Islands, why it is happening in Barren Islands, what is the location of Barren Islands, how is it that Andaman Nicobar group of islands are created. So Andaman Nicobar group of islands are created as a consequence of volcanic eruption. Why volcanic eruption? Due to the convergence of the oceanic crust of the Indian plate and the oceanic crust of the minor Burmese plate. They have undergone convergence, and that is why the volcanic eruption. Then we have discussed about the Indonesian arc. What happens in general with oceanic-oceanic convergence, the type of landforms. Then after that, we have taken a look at the other examples of oceanic-oceanic convergence: Aleutian Island Formation, Filipino Island Formation, Tonga Island Formation. All these are outcomes of oceanic-oceanic convergence. Then oceanic-continental convergence. There, for example, African plate, with the case of the Atlantic, there you have the Atlas Mountain Formation. South American with the Nazca Plate, Andes Formation. North America with the Pacific Plate, there you have the Rockies Formation, Coastal Cascade Range Formation. There also you have the formation of a trench. These are active seismically, and they also experience the formation of fold because a continental plate is involved, so they can accumulate. They are lighter in nature, and volcanic eruption. Mount Cotopaxi in South America, Mount Rainier, Mount Hood, Mount Shasta, all of them in the region of North America. They are because of oceanic-continental convergence. And the third kind of convergence that we have studied, which has led to the formation of Himalayas, is basically continental convergence. And that is where you have the thickening of the crust, the pressure is exerted, which is very high, no volcanic formation, no trench formation, but very high magnitude earthquakes and tall fold mountains. Example, Himalayas, Alps, Ural. So that in a way is a compilation, and that is all that you need to take a look into for the examination preparation. Take a look at the previous year question. Let us know with the answer in the comment section below. I hope that this has added information to your existing knowledge set. If you have liked the content of the video, put that in the comment section and do bless us with a like, share, and the subscribe button. Till we meet again tomorrow, take care. Goodbye. Thank you.